Alright guys, today we're continuing with graphing quadratic equations. Here I have an example of a quadratic equation that is in vertex form. What I'm going to do is I'm going to graph this quadratic. I'm then going to talk about how it was moved. I'm also going to find the vertex, the the axis of symmetry, the x-intercepts, the y-intercept, and the domain and range. Okay, so we're going to find 6 things after we graph this. To graph this quadratic, the first thing we need to find is a set of points that we can use. The first point that you really want to use or focus on is the vertex. And the way you find that is you just look at your quadratic in general. We have x plus 4 squared minus 2. X plus 4 tells me that I'm going to move this graph to the right 4 spaces. So that means I'm going in the negative direction, or negative 4. And then if I look at my k value on the outside, I have negative 2. This means that I'm shifting my graph down 2 spaces. So again, in the negative direction, at this time negative 2. This is going to be where my quadratic function sits. And that means this is my vertex, negative 4, positive 2. So knowing this, I can create a table of points that can help me graph this function. Let's create that table. I know that my vertex is going to be negative 4, 2, so I'm going to put that in the middle of my table, and I'm just going to choose values that are on either side of negative 4 and find my y values. So for the rest of the x values, I'm going to go with negative 5, negative 6 on the lower side, and then negative 3, negative 2 on the higher side. So if I plug in negative 6 plus 4 is 2, 2 squared is 4, 4 minus 2 is positive 2. If I plug in negative 5 plus 4 is 1, 1 squared is 1, 1 minus 2 is negative 1. If I plug in negative 3 plus 4 is 1, 1 squared is 1, 1 minus 2 is negative 1. And if I plug in negative 2, I'm going to end up again with positive 2, because negative 2 plus 4 is 2, 2 squared is 4, 4 minus 2 is positive 2. So these are the points I'm going to use to graph. Like I said before, I'm actually going to plot, I'll keep it all in black. So for my first point, I have negative 6, positive 2. And I'm just going to put a dot about where those two meet up. So they meet up about there. So that's how I get that dot there. Negative 5, negative 1 would be about here. Negative 4, 2 would be here. Again, this is my vertex. Negative 3, negative 1 is here. And negative 2, positive 2 is going to be up here. If I connect those dots, it will give me the graph of my quadratic function. And I can find everything else that I need from here. My vertex is at the point negative 4, negative 2. So that's there. Again, that's the vertex. Okay. Next, what I'm going to do is find the axis of symmetry. I know that the axis of symmetry is the vertical line that cuts my graph in half. So if I cut my graph in half with the vertical line, this is my axis of symmetry. The axis of symmetry always comes from the x value of your vertex. So our vertex has an x value of negative 4. This means our axis of symmetry is x equals negative 4. My x-intercepts are where the graph crosses the x-axis. And I'm going to have to actually find those because it's not very clear as of right now. I know that I have two of them because my graph crosses the x-axis at 2 points. One right here, one right there. So I know I have two x-intercepts. I just have to find them on my own. To do that, I'm just going to put this equation and all I'm going to do is change out the value of y to be 0 because when my graph crosses the x-axis, the y value is 0. Now I'm just going to solve for x by adding 2 to both sides. This will get me 2 equals x plus 4 squared. Then I need to square root both sides. This is actually going to get me a decimal. The square root of 2 1 second, let me get my calculator in the correct mode. The square root of 2 is equal to 1.4, so this is going to be a positive 1.4 equals x plus 4, and a negative 1.4 equals x plus 4. I have two values, so I get the positive and the negative value. To solve, I'm going to subtract 4 from both sides. This means x equals negative 3.4. And this means x equals negative 5.4. So those are going to be my two x-intercepts. And I'm going to rewrite them exactly where it says x-intercepts just so I can get this out of the way. So let me get rid of this. Remember those values, negative 3.4, negative 5.4. So those are my x-intercepts. My y-intercept is where my graph crosses the y-axis, and it doesn't look like it does cross the y-axis, but in all reality, quadratics will always cross the y-axis, so we're going to have to find this on our own. What I'm going to do to find my y-intercept is I'm going to take my equation, and I'm simply going to trade the value of x for 0, so y equals 0 plus 4 squared minus 2. Which means y equals 4 squared minus 2, y equals 16 minus 2, y equals 14. So that means our y-intercept is at the point 0, 14, which we could assume is going to be way up there. This would be where our y-intercept is. Right? So again, I'm going to get rid of this, and I'll just put the value there. My y-intercept is at the point 0, 14. Domain comes from the arrows of our graph. The arrows of our graph tell us all the x values that could possibly be covered by our graph. So this arrow and this arrow help us find our domain. My left arrow has a domain, has a coordinate of negative infinity, positive infinity. Because it's going to the left on the x-axis, that means it's going in the negative value, but it's also going up, which means it's going to the positive value on the y-axis. My right arrow has a value of infinity because it's going in the right direction, which means it's going to the positive, and it's also going to the positive in the y direction. So those are my coordinates for my arrows. My domain of this function comes from the x values of each arrow. So my x values are negative infinity and positive infinity, and that's going to be my domain. My range comes from the y values off of the arrows, which are both positive infinity, also the y value off of the vertex. So my range is going to be from -2 to positive infinity. All right, we have graphed, labeled, and found all of the pieces for our quadratic equation. Have a great day.